using the reaction quotient to figure out if a reaction is at equilibrium, and if it's not at equilibrium, you can use the reaction quotient to predict which way the reaction will shift so it can reach equilibrium. So anyway, so there's a way you can write an equilibrium expression using K if you're at equilibrium, but if you're not at equilibrium, they use this symbol Q called the reaction quotient just to show that your expression is not necessarily at equilibrium. So let me show you how to do it. So the first thing that you're going to do is you're going to write the expression, but instead of with K, you're going to write Q. And so you write the expression the same way as you would write an equilibrium expression. You take the product, so this is the COCl2, and it's to the first power because the exponent would be 1 because the coefficient is 1. And then you're going to divide that by CO to the first power, Cl2 to the first power. Okay, so the Q just means you're not necessarily at equilibrium. So then what you do is you plug in the numbers. So Q is equal to COCl2, which is 5.0 molar. And then the CO is 2.5 molar. And the Cl2 is 1.2 molar. All right, and so then you would do all that math, and you end up getting that Q equals 1.7. Now, if that equals K, you're at equilibrium. So if Q equals K, that means you're at equilibrium. But as you can see, K in the problem that was given, or Kc, is equal to 13.8. So Q does not equal K. Okay, now, so what you got to think about, which way would this reaction shift to make Q approach K? So anyway, what you look at is you see, well, Q is less. And so we got to make the Q bigger so 1.7 can get closer to 13.8. So what number would we have to make larger in our expression here to get the number closer to 13.8? Well, as you can see, it's smaller. So if we make the number on top, which is our COCl2, if we make that larger, then our Q number will become closer to K. So the reaction is going to shift to the right. Okay, so it's going to shift to the right. So it's going to shift to the right. Okay, that way we'll make more COCl2. The concentration of that will increase, and then that will make Q become closer to K as this starts to increase. All right, so that's how you can use Q to see if you're at equilibrium, and if not, you can predict the direction of the shift. That's it.